Good day, everyone. My name is Tandy, and this is my YouTube channel. In the previous two videos, we have already talked about electric current, potential difference, resistance, and also we have done a second video was on a resistors that are connected in parallel or in series, and then just continuing on our lesson on the electric circuits. In this video we're going to be talking about internal resistance of battery. So this is the third video. If you have not watched the two previous videos, I would suggest that you do so. They will be beneficial and you can use them for revision, exam preparation, or if you're looking to just refresh your memory on a few basic concepts. So like I've said in the previous two videos, this is aimed primarily at grade 12 learners. uh yeah, physical science learners. If you're doing physics in school, you might find this beneficial. So yes, remember to subscribe, to yes, and like, comment. You can even dislike if you don't like something, you don't like it. But in all, if you do that, just leave a comment, tell me where I can improve. This is, this, I'm still learning how to kind of get used to everything and to be in front of the camera as well, even if it's a small camera in this case. Yes. So yeah, let's get right to it. Like I've mentioned, so I'm just gonna remove my face for a while. Yes, like I've mentioned that in this video, we're going to talk about internal resistance. So if you have just consider a battery, take for an example, a battery. So a battery that you buy at the shop, and then you will see on this value there, on the battery, you will have a value there written 9V. So that is 9 volts, and then you have a negative terminal as well as a positive terminal. So this is your battery, whatever brand of a battery you think about. So if we were, for an example, to take this battery as it is without connecting it to a circuit, and then we take it and we connect a voltmeter, so an electrical device that measures the potential difference on this battery, you will get a value. So you will get this value 9V. So you, on that voltmeter reading, will give you a value of 9V, which is 9 volts. And then what we do then, after doing this, we will, okay, cool, let's connect now this battery to an external circuit. So we connect it and we have a sort of an equation. So apologize. So let me just find the eraser quick. Okay. So you connecting it to an external resistor. That value, and then you measure it again, you will find a lesser value. So that value that you'll be reading now will be the circuit voltage, and it will be lesser than the 9 volts that you would, perhaps let's say it's 8.5 V. So what is the cause of that? Why are we getting two different values? Shouldn't this battery be supplying a potential difference of 9V? So the answer to that is that batteries, real batteries that you use in real life, are made of substances or material which have resistance. So the material that this battery is made out of has a small resistance to it. So they are not only sources of voltage, but they have internal resistance. And this internal resistance, we can uh, refer to, the symbol for that, we can use a small letter R. So I want you to imagine inside this battery of yours, you have a small resistor there. So you have a small resistor providing the internal resistance. We call it internal resistance because it's inside the battery. And then here will be the external resistance. So that is the resistance from the circuit. And this value that you read, that you will measure if the battery is not connected to an external circuit, we refer to that as the electromotive force, or the EMF of the value, and it's represented by this epsilon is the Greek letter epsilon. So that will be your EMF, and then this will be your circuit voltage that you get. And then the difference between these two, then that will be the potential difference. Yeah, the potential difference for the internal resistance there. So if we were to connect the voltmeter there, then if it was possible to do that, then we would read the value would be just the difference between these two things. So that internal resistance is actually what causes this value to drop. So the value that you actually get in your circuit is not actually the total voltage. It is the electromotive force minus the potential difference needed to overcome that internal resistance of the battery. So let's just move on. So yeah, so now you see we have now a picture there, an image of a battery. We have the positive terminal here, we have the negative terminal here, and then that is the electromotive force, the EMF of the thing. And then you see it's almost like that internal resistance is connected in series with the EMF. And then now our resistance, our battery is connected now to also an external resistance. So this external resistance, we all often refer to it as the load. So the load is the external resistance in the circuit, and then the small r is the internal resistance of the battery. So we have that. So we, like I mentioned, is the internal resistance is provided by the small letter r. External resistance of the circuit is the big R there, and then this is your EMF value, and this will be the circuit voltage that you will get. So we know from the previous two videos, when we in the first video we spoke about Ohm's law, and Ohm's law basically is just something like this: R is equal to V over I. So from this law, we see that we can actually find the potential difference on the external resistance, which we called the load. So that is why here we have V load, which is nothing but, when you multiply. So if you want to make this the subject of the formula, you just multiply R and I, then you get the potential difference of the load or the external circuit, the external voltage, of the external resistance. And then again, from Ohm's law, we can still find the internal resistance, the potential difference needed to overcome the internal resistance of the battery, and that will just be also the product of current. But here you see we use the small letter r, and then here we use the big letter R for the external resistance. So yes, and all of these things, so your EMF, your internal resistance from the battery, your external load resistor, all of these things can be represented by this formula here, which says E, or the epsilon, equals to V plus IR. So this is your circuit voltage, and this will be the voltage from the potential difference of the internal resistor or the internal resistance. And you can just make V the subject of the formula, and then you'll see that the value that you will actually draw from the battery, the potential difference that you'll be able to draw from the battery that will be supplied to the external circuit will be the EMF less the internal, the potential difference of the potential difference of the internal resistance. So work will have to be done to move a charge from here to here. So that is why we minus that. Another interesting thing with that we can also learn about, that we often find in questions, is that there's like a maximum value, or the maximum current value that you can draw from a battery. So for example, let's say consider the same battery that we have. So those are the two terminals, the positive and the negative terminal. So we'll say this is the positive terminal and this is the negative terminal. If, for example, we were to connect this to a wire, so now if this is like this, we have a complete circuit. But for our wires, let's say ideally, hypothetically, our wire does not have any resistance at all, so current can just flow as freely as it possibly can. So if this situation is like this, it means we have maximum current flowing through that circuit from the negative, from conventional current, from the positive to the negative. We have maximum. We have a flow of charges that are just moving freely. Those electrons are just moving freely in your circuit from this terminal to this. So that is the maximum current that you will have. And then now, so like I said, the wire has no resistance, and yes, and but now what you want to do is that if, for example, there's no resistance, right? If, for example, now we put a voltmeter here, we measure the potential difference, the circuit potential difference, it will give us a value of 0. Why is that? It gives us a value of 0 because there is no work that needs to be done. Charge just flows freely. There's nothing that is acting against the flow of charge. So if there is no work being done, it means the potential difference is 0. And if the potential difference is 0, we can revisit that equation that we talked about in the last slide, and where we equate V. So this is the circuit voltage to 0, and then we still have the, we will be given a certain EMF value. Let's say that will be 9V minus the maximum current, because if the voltage is 0, meaning if the potential, the circuit, potential difference, the circuit potential difference is 0, it means maximum current is flowing through our circuit. Then we have that IC with a small letter C there, and this is the internal resistance, the value of the internal resistance. And then we can just rework that, do a little bit of mathematics, and then we can actually have a formula giving us an approximation of how the approximation of the maximum current that you can actually draw from this battery of ours. And it says that that value is just less than the ratio of the EMF divided by the internal resistance. So they can normally ask this question. If they ask this question, they say calculate the, or estimate or calculate the maximum current that can be drawn from a battery. Then you know, go to, oh, if that is the case, there's no potential difference being done, so I can just equate this to 0. I have the EMF value, perhaps it's given, as well as the value for the internal resistance. Then I can come to find an estimate of the maximum current that our, what is it, that our current, that our battery can supply. So this brings us to the last, so this brings us to the end of this video. So the last video on electric circuits, which will be posted after this one, we'll be talking, I'll be doing questions. So I'll be doing questions from previous question papers. I don't know how many questions I will do, but I'll try to do as many as possible, or at least, even if it's not as many, find a question that is all encompassing, that it includes everything, so that you can be able to see how we can solve some of these problems if they are given to us in a question paper. And like before, if you do not understand something, please leave it in the comment section. I'll also leave my details, my email address, social media handle, that type of stuff, so that if you want to get in contact and you need more clarity, more elaboration, that you can always talk to me. But for now, that is it. I hope you enjoyed, oh, I hope that you learned something from this video. Please don't share the link with your friends, subscribe, so that when I post another video, you can just receive that notification. Thank you so much.